Thank you all for coming. This is C# Skeletons, tongue-in-cheek look at some of the spooky aspects of C#. So, oh, I nearly forgot the most important bit. A spooky hat. There we go. So, okay. Okay, yeah, so in the dark, no one can see sharp. Oh, scary. So we're going to start off looking at spooky strings, which are wolves in sheep's clothing. We're going to jump straight into the first demo. So the first weird thing that we're going to look at is how strings have no idea what they're supposed to be, and they're sort of they're reference types, but they're really value types in practice, and they sort of live are referred to by reference, but sort of aren't, and also you can't change them, and they're just a bit mental and a bit crazy. So when I'm working with, say, ordinary primitives, I can go, you know, var I equals 1, and I can just declare my stuff as I want. Normally, if I want to create a reference type, I have to go, you know, var some object equals new whatever. I can't just refer to it as a primitive. Strings, however, are a little confused. With a string, I'm perfectly allowed to just go like that, and everything is fine and everything is happy. Now, it's a little bit weird because we also know that if I create two reference types, so if I call this var s1 and var s2, and I give them exactly the same stuff in there, because they're reference types, these should be different things. I'm declaring two different reference types here. But if I sort of write out, if I go, let me check, I've not spoiled a surprise. There we go. Don't want that in there.
Perfectly safe library.
Perfectly safe library. That's right. Everybody come here, relax, bring your money. Okay, so I can say S1 equals S2, and what will we get? I'm sure everybody already knows the answer to what we get off of that. When we run that, we get a variable I, and we get true. We use them every day, so we don't think about it in the slightest as to why that might be, or even why that shouldn't be. I definitely, if I created a dummy class here, just went, and if I created two of those and then tried the same thing, so var 1 equals new dummy, and var 02 equals new dummy, and then I tried to do the same thing with those and said is 01 equal to 02. That's definitely a 0. That's a 0 as well. That's the O button. Then things will happen as we expect them, and it will say, nope, they're not the same thing. So let's have a look at what's going on. We'll get rid of this, I'm sure we all don't need to keep looking at that. But we can actually have a look and see whether these are the same strings. I can say, I go CW, let's go S1 is S2. And I'll say, are they referentially equal? S1 and S2. And they are the same thing. They are literally the same bit of memory in the CLR as it's running up in our domain, which goes against everything we know about reference types. The other thing that we can do, or other thing I wanted to show you, is why we had the S1 equals S2 coming back as the same thing. Let me now go in here, and I'm going to try and confuse the CLR by not giving it the string directly. I'm going to say, I'm going to give it a new string, and I'm going to pass in because we all know that strings under the scenes are just arrays of characters with some fluff. So I'm going to go s1 dot two character array. So that's just going to convert it back to what it is under the scenes. And we'll try again. Now we'll say reference equals, and we'll say s1, s2. There we go, go to that. And now I say that they're different, which is, again, really, really odd, because why do I have, these are the same things. They're both strings. They should both be using exactly the same way of checking that they are each other. But it doesn't work anymore. If I try and do an equals on them, though, let's go s1 equals s2 again. What do you think will happen? That's right, you are all completely correct, and they come out as true. If we actually look to find out what's going on, we sort of need to go under the scenes a wee bit. Or into the dark corners. Woo! Okay, so we're going to go to the reference. Whoops, reference source C#.
The only day you can get away with that, isn't it?
Yeah. And we're wearing this hat. Any other day, I'd be locked up as being deranged. There's a wire in it as well, so I can change the way that it hangs. So value for money as well. Okay, so let's have a look at the system.string. And we will find the equals method in here and see, come on, Control F, find. Why aren't you finding? Control F, there we go, find. So let's go equals. So we can see our equal method initially looks reasonably typical. It accepts an object. It says if the other object is null, then obviously it's false. So we short circuit there. If they happen to literally refer to the same bit of memory, then they must be equal. So we return to there. But after that, it gets a bit stranger. Now we actually drop in and check the string's length of each other and say, but if they're not the same length, then they must be different. And if they're the same length, then it drops down further into this equals helper in here, which is an albeit highly optimized big for loop that goes and checks each individual character all along. So the implementation in CLR actually overrides the default behavior for equality on a string so that it doesn't behave like a reference type, it behaves like a value type and checks that the two values are exactly the same. That's our first spooky string thing, is that it pretends to be a value type. When you sort of realize that, it also makes sense now as to why strings are completely immutable. It would be crazy if I could have a value type that was actually a reference type, but I could change the value of it because things would point at it. Everything would go mental, and cats and dogs living together kind of stuff. So the next we have, back to the slideshow. Some are immortal. So some strings, once they're there, you can never get rid of them until you shut down the program. So let's see why that is with another demo, a spooky demo. Let's get rid of this stuff here. So what I'm going to do again is I'm going to create a new string, S1. Oops, sorry. S1 equals, and what I'm going to do is pass these two things in. So string args. I'm going to say S1 is equal to arg0, arg. Woo! Args1. And then I'm going to do some same things. I'm going to say S1 equals S2. And I'm going to say S1 is S2. And we're going to check the references again. So I'll save that. This time I'll actually build it using the command line instead of in here, so it's a bit easier to pass the things in. Where am I? Copy path. Oh, yeah, copy path. Die! Woo! Die! Don't type in die. Okay. I want to go into Halloween, and I'm going to go CSC program CS. We'll build that. Should all be good. See, hello. I'll shift this over to this side so that we can compare the two that's going along. So I get that they equal again. That's good. We know that's true because we've already established that these get compared as value types, and they're false. Okay, we kind of could have guessed that because we'd already seen that as soon as we confuse the CLR with what's going on, it can no longer tell, and it creates two separate instances in memory for it. There's a big difference, however, if I put one in here and I go var s3 equals hello. This S3 is special because at compile time, we know that this string is going to be needed. So it's embedded in the assembly, obviously. When the CLR loads, it initially takes all of the strings that it knows about and chucks them into a special immortal bit of memory called the intern pool, and then tries to balance performance against memory usage by saying, oh, you created this string. Instead of using that string, what I'm actually going to do is I'm going to point at a reference in the intern pool, and you can use this string instead, which generally works quite well. I won't bother proving it again, but you can all appreciate that these would have three different memory locations right now. There may be times, and you certainly should do this, if you have long strings that you're going to use a lot, maybe templates or something like that, then you should intern your pool. So if I go var interned, actually, let's just check first. So I can say CW is interned. We'll check if S1 is interned. And we can use the helper method of the string dot is interned. Is interned will not return true or false. It will return either a reference to the string that's in memory, or it will return null. So just actually say whether something is interned or not, we just say, is it not equal to null? Let's try the same thing with S3 here, which is the one that we had hard coded. And obviously S2 is going to be exactly the same sort of thing. We'll compile again here. Ooh, that's no good. Isn't it right time? No, oh, there we go, S3. So, I didn't expect that to happen, actually. But it is quite good because I couldn't fake that. I was wondering if I could fake this weird behavior that can happen in the intern pool. So what I was expecting to happen is that S1 would say, I'm not interned because I passed it in. The CLR doesn't know about it, and I pass it in. So we will create S2 instead from S1.toCar array, and we'll do that again. Oh, and of course it helps if I do output what on earth is going on. Is interned S1. I am thoroughly confused. Ah, my mistake. I'm sorry. So S1 isn't interned. However, the value is interned. Sorry, stage fright. So S1 has come in. They all have hello, and this is returning whether the value of hello exists in the interned pool. And as all of these are created, they all have the same value. So the is interned scans to the intern pool and says, do I have this value in there? If so, give me back a reference to that value. I'll change the hat so that it's, there we go, that's better. Once we've done that, what we can do is, I'll just do it with the first and the second one. We can say var intern equals s1, sorry, string dot is interned, and I will then compare, do a reference compare again, reference equals, and my interned, and we'll compare that with the S3, which we know is interned because we passed it in from scratch. Have I gone and done something a bit mental there? Oh, yeah. Okay. Force a habit. Let's bring it back over there. And there we go. So this is our last one at the bottom, saying, are they actually the same thing in memory? And they are now. What will happen then is the garbage collector will come along, and this no longer used pointer to a string will just get picked up and cleaned up by the garbage collector as we go along. There is another aspect to this. Let's say that I generated a random string in here. I can also call string.intern, which will dynamically put it in there for me. The CLR is free to choose completely whether it wants to intern something or not, though. I believe that if you tell it to intern it, it has to intern it. However, at any time, it can decide that it wants to intern a string that you've given it. Also, at any time, it can decide that it's more trouble than it's worth to search the intern pool first, and so it'll just chuck another one in. So the intern pool can have duplicates, it can have nothing in it, and if you do a reference equals, you may or may not get the same object in the intern pool returned to you. So the moral of the story is just stick with value equality on strings. Woo! No, that's the it's immortal. Once they're in there, they're in there. You can never get rid of them. The plus side is you don't have to worry about fragmentation because it's an add only. But theoretically, I've never managed to get it to do it. It could grow to the point where you get an out of memory exception, and then you have to pull down the app domain. I believe that actually it's attached to the process as well, not the app domain, which means you actually have to pull down the entire process. Even killing the app domain won't work. Do you want to let me, is this working? Yeah, so the question was, is there any way to purge the intern pool? Can we flush it in any way? And the answer is no, you can't. They're completely immortal. They carry on living until what I believe is the entire process gets pulled down. It might be the app domain. Technically, I think it might be undocumented, so they're free to change that whenever they want. Okay, the next thing that we're going to do in our terrifying, spooky. Okay, mind control can really ruin your day. Demo 3. Bonus points for anyone who can pick out all of the monsters all the way through. That was quite fun trying to find my favorite monsters. Okay, so let's get rid of this and let's do something really, really simple. You can forget about the madness of strings, and now we can look at the madness instead of something hijacking your program and controlling it. So let's put console right line, and our hero, our character, he thinks he's finished slaying all the monsters, and so he's home, safe and sound. Smiley face. And we run it, and there's no prizes on this one for guessing what happens when we run a right line with a string around it. It says, yay, we're home, we're safe and sound. However, I have, as some of you noticed, this perfectly safe assembly by here. Now, assembly is a library. they should be safe things. Certainly when we go and reference an assembly, we don't imagine that it should change anything purely by the act of referencing it. We definitely wouldn't imagine that it could hijack an existing function and change it into something else that you want it to be. If we were to call methods on it, then maybe we might give it a bit more leeway and say, well, okay, well, I at least poked you so you could do something. But we're not going to do anything at all. We're just going to reference it. And so add reference to my perfectly safe assembly. And what do you think will happen now? I've stolen your soul. Ah, woo! Anybody got any idea how on earth just the act of reference in a library can cause an existing program to completely change its behavior? This one I'm quite proud of because I figured it out. So the gotcha is up by here, our namespaces. I'll give you a clue. So if I take this here and I put it out there and run it, it's home safe and sound. Any guesses yet? I'll give you one more clue. I can put this back in here if I want. And is this system here, is this a fully qualified reference or a relative reference? That's right. It's a relative reference. If we want it to be a fully qualified reference, we've got to actually explicitly say.
So in that perfectly safe library, it's overridden what console write line does, right? In that other assembly, is overridden what console write line.
No, console.writeLine still does everything that it should do. Bit impolite, just referring to me as Banks like that. No, console.writeLine back here. It's still there. It still exists. It still does everything normally that it should do. But oh, now just put the answer. Come here. There. What the hell? Right. This one. How many copies of that have I got? Yeah. So, but by adding the global in the front of this, I tell it that the namespace that I'm importing is the system that hangs off the root namespace. So it's home safe and sound. Without that, depending on where you put the using, it will change how the assembler, or whatever bit of it is, the linker, I don't know, but how it resolves that namespace. Inside like this, it will go, in the Halloween namespace, do I have a namespace called system? And if the answer is yes, it will go, right, well, I'll use that one. If I move it outside, it goes the other direction, starts at the beginning and goes, do I have anything from the beginning which has the word system in it, in which case I'm going to come up from that way, which means that I can just go in here, and as you probably all saw popping up, if I create a system namespace in Halloween, and I create a console class, and I create a method with the same signature, I can totally hijack the method and tell it to use my method instead. Which is a shame, because I really like the style of having the usings inside the namespaces, because it collapses everything down and you can see clearly, oh, this is a system thing, this is stuff that I'm doing. It makes everything very easy to see. But it does mean that if you're planning on doing that, you should probably stick a global in front of it if you're hoping that something comes from the global. So what have we got next? I think I moved through a bit too quickly. Slideshow, slide spooky. Okay, demo 3. Ah, yes, okay. Sometimes killing it once isn't enough. Sometimes they come back. So, does anybody know of anything in .NET that you have to kill twice to make it finally die? Let's remove that. I don't want to move that. We will show you. This one, if you're, we'll definitely get into the sort of stuff that you're just not going to have to worry about now. But it's good to know. It's to do with tasks, and certainly if in modern C# you ever writing something with the keyword task in it, then you're, sorry, with the keyword thread in it, then you're already kind of broken. Don't do it. But there is still code out there that uses them directly, so we do have to know a little bit about them. So to create a task, I need to just create a method for the task to invoke in itself. So let's just say, I'll call it counter, and all this does is for var I equals 0, I is less than 10, I plus plus, and let's just say we'll go tick. And we'll just wait for a quarter second.
Excuse us, we've got a meeting to go to, sorry.
Okay.
Thank you.
Okay, so if I go rt equals new thread, and I'll pass in counter as the thing that it wants to invoke. And I've forgotten to make that static. Then what I should see is nothing happened. Reason being that this is a background thread, so it's not allowed to keep the application alive. So if I put this background false, that's not how you write C#. In the dark, you can't C#. Oh, it's not because of that. It's because I'm not running it. It helps if I start the thread. Certainly, that's going to have more of an effect on what goes on. There we go. Tick, 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 all the way down. Threads by default start as foreground threads, and I believe by definition an application is determined as finished and should be cleaned up when all the foreground threads are dead. So as long as there's a foreground thread still going that isn't the main thread, it will exit. If, as you just saw there, if we put in a background, then you'd see it will just semicolons everywhere. There we go. Then it just exits without doing anything because it's not a foreground thread. But what would happen if this was going on for a little bit longer? Let's say this goes up to 500, and I started the thread, but after, let's say, after 2 seconds, I want the thread to stop. I can give it an abort in here. I'll have to do this on the command line, but I'll show you why quickly. If I run this right now, this is a .NET Core project rather than a framework project. I get this exception, platform not supported exception. For reasons which I'm sure are very, very good, .NET Core simply doesn't support thread.abort and throws this exception and doesn't do the thread.abort, which might seem like a trivial thing. It's just a different exception that it's throwing, but you will see it's actually quite a bit more sinister than you might imagine. So let's kill that and let's go over here and let's recompile program.cs. And we don't need to pass anything in anymore. So tick, 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 and it stops. Now, the reason it stops is because the thread.abort actually raises an exception inside here called thread aborted exception, and that's what brings the thread down. We can catch this exception. And what happens when you catch an exception? Do things carry on or do they stop? As in, does the exception bring down the thread anymore or does it bring down anything? Let's the thread abort exception in here, and we'll go tidy up. So theoretically, I'm catching the exception, and oh, I can't do it through that. I have to do it through this. Okay, so let's build this. And now let's run it. So what I'm going to do there by here, t.join tells my program to stop at this point and wait until this thread is finished and returns control back to it again. So that's what I'm going to do here. So effectively, it's the recombining of jobs. Now, aborted, and then it stopped, which isn't what we would expect, is it? We've caught the exception. We know we've caught the exception because it's triggering this in here. We know that it's broken out of this. But if I go on here, I've handled this. It should be fine to carry on now. It should swallow up the thread and keep me going, but it doesn't. Why doesn't it do it? The thread abort exception is another unique special exception type that has special permissions and special ways of working underneath the scenes. You can catch a thread aborted exception and you can do things with it, but it will still bubble up and stop the thread. You can't stop it, except you can. Woo! If I go in here and I say thread reset abort, and now I try and do it, it's alive! It's come back from the dead. Wow! Isn't this brilliant? But I don't want it to do that. I want it to die. So what do? I'll try killing it a second time. And there was a little hint earlier as to whether this will work or not. Let's put a thread sleep in there again. We'll just give it one more. It'll tick over, and then we'll try and abort it a second time. It's still alive, so it goes through there the first time. But because I'm not programming it correctly, it gave us exactly the same mark, and so regardless of whether it would carry on or not. So I'm going to stick that in there so it will carry on going tick alive. Woohoo! So we get one tick after the alive, which is what we expect. We put that 250 in there, and the second abort finally brings it down and kills it. So when you try and abort a thread, your first request is a suggestion to the thread that it might want to stop now. The second request is a stake through the heart to finally kill it. And the thread can't do anything. It can't do a second reset abort. It's only allowed to call that once. So let's see, what did I have that was next? Let's slideshow. Scary monster. My favorite monsters, demo 4. Okay, this one, I'm just getting really, really pedantic. Now, we have structs. Certainly, I think it's common among people who might be less experienced. There's a sort of belief that structs are faster, and therefore you should use structs when you want speed or something along those lines. It's completely untrue. They're just a different thing. A struct is a value type. There's a reference type. Performance really has very little to do with it, bar in certain circumstances when that might be better or worse. The most important thing is the semantics around them. Value types are copied by value. Reference types are passed by reference. So let's create a struct here. Oh, the other important point about a value type is that it's compared by value as well. And references are by reference, unlike the string, which is compared by value, even though it's a reference. So if I create a struct here, I'll just call it foo. I'll give it some data. So structor, let's say string s, and I'm going to say that public string s get, and I'm going to say s equals s, and I need a semicolon. So I'm going to create two of those. So let's call it var foo1 equals new foo, var foo2 equals new foo. And any guesses as to if I say foo1 equals foo2? Foo2 foo2? Oh, sorry, I forgot. You can't actually do an equals with a right side. You need to do a dot equals. Okay, true or false, do you think? False. True. So the reason being, of course, that these are value types, and what the quality should be doing is simply going to the stack, looking at whatever the thing is that's on the stack, and comparing those two values. These both live on the stack, so it just scans through the data and says, yeah, that's the same data in there, that's the same data in there. Whereas for a reference type, it would look at the stack and it would say, oh, there's a pointer there, and it's the same address in that pointer as this one over here has. That's why we have the difference in behavior. So it's sort of how we'd like it. It's not quite that straightforward, because without the addition of extra attributes on here, we can't guarantee that the data is actually in order on the struct. We can force it to be that way if we need to. Quite often, if you're passing it with an interop into C++, say, you'll want it to be in a certain order in memory so that C++ can come and can just read a start to finish whatever's in memory and then serialize that into its own type. So we have an equals, and they're the same, and that's fine. If I put something in here, I meant to do this first time, so let's go hello again. I just forgot to type that in. It makes more sense if we actually put some data in, of course. So there you go. Yeah, comes out as true of both of them. And let's go. Let's put H in. Oh, yeah, put H in there, and then let's run it just to prove that false. Cool. What do you think will happen if we have a private variable in here? Private string. Let's go s equals. Let's go. We'll pass in. S1. Probably makes more sense if I just name these things properly. Let's call it private S, and S1. Now, why is it getting angry? Oh, because I'm make sure those in there. So let's go hello in there. We'll pass hello in there as well. And on this one, we'll pass in A, and this one we'll pass in B.
You'd expect the same behavior as before.
You would expect the same behavior before, because they should be encapsulated inside and nobody else should be aware of it. So false. So what's going on? To find out what's going on, we need to go and actually have a look in the equals method. So over to reference source again, or actually easier to just push F12 on that. The first thing that you should notice in here is the namespace imports at the top. There's one there out of those two that absolutely should not be there, and it's the reflection. What the hell is reflection doing in a method which is just supposed to be comparing values? And the answer is it's reflecting both types, getting all of the internal and external, so all of the instance variables, all of the public variables, and all of the private variables, iterating through them, then comparing the values of them all the way down, which is an incredibly slow, tedious process for it to do. To give you an idea of the difference, oh crap, I didn't. I did, and stupidly left it on my other computer, create a very, very big struct with lots of copy and pasting going on to create like a 50 odd properties on it. But we'll try, we'll do quite 50, but we'll do a few on there. So let's say that I'm going to call this default equals. And we'll go PUBG string, and this can be, oh, and this can be S01. So we'll do a few of these. 2, 3, 4, 5, 6, 7, 8, 9, and right at the top, let's have a 0 as well. Let's have a 0 as well in there. And of course, I'm going to have to pass all those in. So they're all equal to that. And then up here, I'm going to create. So if I copy these out, we'll do some sublime text foo. And I'm going to go. Now I've got a whole bunch of variables I can pass in. And I copy that again. And I just change this, I get rid of the string. Then I can go. Okay, so I have one default equals, and I have another one right here. Let's kill that. Whoops, sorry. And we're going to do the same thing. Let's rename this one to default equals 1. 1, and we'll rename this one here to default equals 2. Okay, so everyone can sort of see what's going on there. Yeah, I've created a whole bunch of properties. I've assigned them the same identical data, and I'm going to pass them in. Now, what I'm also going to do is I'm going to create another one of these, which has an implicit override of the equals. And I'm going to go, what do I want to do? I want to copy those, don't I? So if I go, don't want any of that. Oh, 3. So I'm going to say this dot equals other dot, and I want that. And so if I go in here, I want to duplicate all of that. Rename this to explicit equals. And at the top here, I'm going to go public override equals. Whoops. Kill this, and I'm going to say var other equals. We're passing in an object, so I'm going to explicitly cast it to an explicit equals. Paste that in, and I return that. Cool. Everyone happy with what's going on so far? Obviously, you would never do that on an equals in the real world. Now I'm just going to copy and paste the top bit, and then we're going to do the same thing, except with the explicit equals. So you are going to become explicit equals. You're going to become explicit equals. Explicit. Explicit. That there becomes explicit equals. Oh. And that one there becomes explicit equals, and then you go there, you go there, you go there, you go there, and you go there. Cool, so hopefully those two things will have exactly the same output because I'm passing in same things. Method must have, oh, yeah, that needs to be explicit equals. So if I've done it right, should. Okay, so we're all good. And what we've changed is we've replaced the default equals with one that just goes and calls each one. Now let's put a stopwatch around these two things then. So let's go var s default equals stopwatch dot start new. I need to have a just a result here, because otherwise the optimizer may well just decide not to run it at all because it realizes we don't use anything in there. So b equals default 1 dot equals default 2, and it's default dot stop. And then we'll do the same thing again with the other one. We're going to go var s explicit, and that's going to be another stopwatch. And we are going to go b equals explicit 1 dot equals explicit 2. That's explicit dot stop. And then we'll just dump them out. And this one, the top one is a default. And this one here can be the default. Let's try running it. And there's your difference in the amount of time it takes for one compared to the other one. It's a non-trivial amount. So that brings us just about to the end to this nightmarish. This is a giant leech from the horror movie Attack of the Killer Giant Leeches. If anyone knew what that one was, then well done. Yeah, that's it. That was the weirdy things that I think are kind of cool and interesting in .NET. There is I have a whole pack of other ones as well. So if you think it's interesting and would like another similar thing with other new things, then let me know. I will do another one. Thank you very much and have a spooky day.